Good morning, class. Welcome back to AET 3830, Internet of Things and Industrial Applications. So for this unit, actually for the remaining sections, we'll move into a new, focus. Basically, in the previous sections, we have viewed the Internet of Things technology as a whole, and we introduced different aspects of the Internet of Things, including its security, its architecture, its modeling, and some concepts in Internet of Things. And from this unit on, we will look into the specific areas of using Internet of Things. Basically, we will look into the asset management, manufacturing, healthcare, smart grids, smart cities. Basically, now we look into the detailed examples of the Internet of Things, and we will see what specific requirements are there in these areas, and we'll also see how Internet of Things technologies are adapted to these different areas. And for this unit, we'll focus on asset management and industrial automation. With that being said, so the objectives for this unit is quite straightforward. We'll have a brief introduction of the discussion today, and then we will look into asset management and industrial automation. We are using Internet of Things. So for each of the area here, so we'll discuss about the specific requirements in those areas, and we will show a few representative projects or implementations in these areas, so that you know, okay, how you combine the knowledge you have learned so far into real applications. So the content in this unit comes from chapter 10 to 11 of the textbook. So for the introduction, so I put it into italic font. Basically, it means it talks about the focus of this unit and the remaining units. It gives an overview of how Internet of Things are applied into different areas. And as I mentioned, for these different areas, we'll focus on analyzing the specific requirements in those areas. For example, you can guess that for the healthcare, the requirement is totally different from the automation and manufacturing, right? And also for the areas we'll discuss, we'll illustrate with some representative examples, some representative implementations, so that will help you gain a better understand. Okay, so for the introduction here, I put it into italic just to help you to get ready for our adventure into specific areas. Okay, the first area we discuss is the asset management. So the emerging asset, basically, usually, for our understanding in this course, usually means the devices, the machines, the goods, the products, basically the physical object, mainly the physical objects within an environment. So if it is in a manufacturing environment, so the assets may include the forklift, the warehouse, the shelf, the pallets, the containers, the machines, those kind of things. So in the case, asset management means how we can use Internet of Things technology to take care of all these objects. The emergence of the Internet of Things and with experience of envisioned devices pose a clear challenge to the management of this. So for Internet of Things, we know that it may contain a large number of devices. Then how we can manage these devices properly so that we can achieve our requirements. It is still a challenge. So just think of this. So for example, now you may have 20 sensors in the system, right? To monitor 20 containers. Then with the introduction of a new container, several new containers, so how can we integrate the new devices into system? So how can we configure these new devices properly and automatically so that we can make use of them easily. So existing asset management practice consider operations applicable to different physical assets to monitor their operations and maybe some adjustment of their behaviors. And within the recent years, so a significant movement has been witnessed towards open protocols. That's what we discussed before, and especially they are related to IP, and they will actually find their way into the industrial settings. So current practice is undergoing transformation as the operational technology and information technologies are merging. Operational technology, usually that means the automation. They can mean the automation in the manufacturing environment. For example, you may have heard of the programmable logic controller, PLC, and CNC machines. And basically, they are small computers. They will control the operations. And for IT, you have known that for recent years, these operational technologies and informational technologies are merging. They come from the heterogeneity of devices. Heterogeneity means different types of devices, from the basic ones to the advanced ones. And also, they were using the open standards. Open standard means that they were more scalable and compatible with each other, and they have more functionalities. And also, the applications based on them can cover multiple layers. The layer here means the 7 layer we discussed before. So from the basic device layer all the way to the business layer. So with that, while all this are happening, a typical nightmare is the configuration of assets in modern enterprise, in order to enable data collection across the enterprise service needs. So, for example, today employees may use computing devices in conjunction with the shop floor OT operation technology such as PLC sensors, and all this need to be accounted for in backend systems and to be integrated. So to achieve this is challenging, basically due to the reasons we mentioned just now. So the heterogeneous devices and the number is large, and they have different software themselves, have different structure. So that's why we need to probably implement asset management to take care of them. And for the expected benefits, the IoT era is dominated by interactions among the devices, access to the data, and dynamic configuration and management of them. With this implementation, we can expect the significant benefits as below. For example, we will have a reduced cost because remotely telemetry without the need for field personnel to be engaged. Yeah, that's basically the typical IoT scenario. Increased quality because the fine-grained monitoring of data can be done even near real time. So if a machine or a product goes wrong, it can be found out immediately. And increased resilience. Resilience means that it is not sensitive to the changes. So for example, recently, so because of the COVID-19, so people are raising the issue of manufacturing resilience. Basically, they want to reduce the impact of COVID on manufacturing so that the companies, especially the small and medium-sized companies, can survive under this scenario. So maybe you have noticed many restaurants are actually closed. But on the other hand, they can open again very quickly. But for manufacturing companies, the closing and the opening is not that simple. So that's why they need resilience to survive. And another benefit is increased performance and security. And remote updates may enhance operation capabilities of the asset. So remote updates, yeah, if you are using the Windows system, you may have experienced the time that when you are trying to turn off your computer, actually it says Windows is updating, then you need to wait for a few more minutes before it can close. And also, one of my students, he was trying to defense, and it is 20 minutes before defense, his computer was updating. So that's a story I can share with you. Also, other benefits include increased security, asset location tracking, especially with RFID and other active sensors. We can clearly tell where the objects are. So if you if you fly very often, then you will notice that actually if you need to consign your package, consign your luggage, you will see some barcode there, right? And some of them actually have the RFID tag, so that nowadays, although it is still quite often, but it is less often that your luggage will be lost. Usually they can still find out where it is, and then they can get back to you maybe in a few days. But maybe 20 years ago, so basically if your luggage is missing, then it will be lost very often. And the IoT also helps for operation optimization and also notice. Okay, and for these benefits, it requires the correct tackling of the many different complex issues. So if some issues cannot be taken care of properly, basically the benefits will not come out, and sometimes it will also bring in some disadvantages. So for example, remote access to device lower integration costs and also reduce the labor costs, right? But basically the technical people do not need to come to the location on site. But this may open opportunities for security attack that may cause some problem. And with the benefits in mind, actually there are some pivotal benefits in the IoT area, so which include the real-time monitoring, predictive maintenance, and intelligence infrastructure management are expected, and the benefits have been found in different multiple domains for asset management using different IoT technologies, so including residential homes, healthcare buildings, cities. So for healthcare, maybe you notice that for some patients, they will have a wristband around their wrist, right? So you can see barcode there, and actually there are also RFID antenna and chips inside. So if the patient intentionally or unintentionally leaves the hospital, for example, then there will be a warning signal, and the doctors or nurses will receive notification. So that's one scenario. Okay, so by now we have given an overview of the asset management using IoT. Basically, we describe what it is and also some expected benefits of doing that. Okay, and then now let's come to several examples, several implementations related to asset management using IoT. One recent focus is e-maintenance. So maintenance, you know what it is, right? Basically, you want to take care of the machine, do some repair, do some checking routinely so that it can work, it can stay functional all the time when you need it. So e-maintenance here means maintenance support which includes the resources, services, and management necessary to enable proactive decision process execution. So the keyword here is proactive. So we don't wait the machine go down to do something. Basically, we try to do something before it goes down. In order to effectively implement e-maintenance applications for asset life cycle management, several requirements need to be met, including the interoperability, and also we need the IT platform to do that. Some strategies for e-maintenance include remote maintenance. So by its name, you know that basically we can access the machine operation data from remote locations. Then we can see whether it is working as it is supposed to. And we can also do the predictive maintenance. Basically, we use models and methodologies to analyze the operational performance of the assets and attempt to predict malfunctioning and failures, and or determine on demand when maintenance checks are needed. So the idea here is that, so most of the time, the machine does not break all of a sudden. Usually it has some symptoms or some signs before. So the predictive maintenance is realized by monitoring and analyzing the data collected all along the way. Another strategy of doing maintenance is real-time maintenance. So current failures on the shop floor, although evident, may require significant time until they are assessed, repaired, and replanned. So with the real-time maintenance, the immediate assessment of the operation factory and enterprise process can be achieved and addressed. And also it facilitates collaborative maintenance, because for many machines, especially for the sophisticated manufacturing machines systems, they may involve expertise in different areas. For example, they may have mechanical aspects, electrical aspects, computer aspects, and maybe optics aspects. In that case, it requires different experts. So if by using the e-maintenance, so different experts can collaborate using a maintenance IT platform, and then they can work on the machine at the same time, which reduce the cost and increase the efficiency. So to achieve these objectives, we have to harness the new capabilities of IoT. So it is open enough so that it can be scaled up and be integrated easily. And also, it will take advantage of the event-driven methods. So the opposite event-driven methods. So the opposite of event-driven method is the pull system. Basically, in an event-driven method, the on-demand report, the depot failures, and the other information are provided when some event happens. So this migration from a traditional information pool to an event-driven system is expected to minimize unnecessary traffic and empower the target information dissemination with the infrastructure. If it is a pool system, basically maybe every hour, maybe every minute, so the center system will send a signal to achieve the current data to see whether the system is functioning well, for example. And usually, maybe more than 90% of the time, the machine is working well, right? So that, in other words, about 90% of the data are not valuable because they're just repeating the status of good performing. So, but on the other hand, it requires the communication traffic. So this may be a waste when the communication bandwidth is limited. But if it is event-driven, that means that no news is good news. So if the machine is performing well, basically the center system will not receive any update, will not receive updates from the machine. So no news is good news. But if something happened, then the device will send information to the center system. Then the center system will know what's happening. So this is a strategy to reduce the traffic. Another key aspect of IoT that e-maintenance can benefit is the dynamic discovery of assets and their surrounding context. Basically, it's just like the plug-and-play approach. So plug-and-play, that means that if you have so you should have Wi-Fi router in your house, right? Wi-Fi router, when you get in to a location close to the router, then actually your mobile phone or your iPad can discover the router. Basically, you can see its icon in the Wi-Fi hotspot list, and then you may need to put the password to join the Wi-Fi router, Wi-Fi hotspot. But as you may have noticed, sometimes the Wi-Fi router, they do not require password. In that case, if you set up something in your mobile phone, actually your mobile phone can automatically join the Wi-Fi hotspot without the password. Basically, your laptop, your mobile phone, or your iPad can join the internet automatically. So that's what plug and play means. But as you can guess, it will cause some security issue. But for the IoT devices, so it is quite useful, because if, for example, for plug and play, now you have 10 devices, and later on you add 5 more devices. So if it is a plug and play system, then the 5 new devices will be automatically configured, and they are ready to work by uploading the data they sense, for example. And as we mentioned just now, collaborative e-maintenance is a promising approach that integrates multi-enterprise experts can together efficiently address any asset issues, and that can also bring new business models. So basically, later on, we will see experts that will see some companies, some service providers, they just do the e-maintenance. Basically, they will help different companies to do the maintenance without going to their sites physically. Basically, they just analyze the data they collected and provide suggestions and solutions. And with e-maintenance, cross-company communication is enhanced with IoT real-time connection to devices, so that malfunctions can be quickly analyzed and resolved. And all this can now collaborate using multiple internet-based technologies with seamless data, voice, and media integration over an e-maintenance platform. So an illustration is shown here. So this is the online collaborative e-maintenance platform. So the asset manufacturer can use this platform to monitor the asset they produce and do the firmware updates and maintenance. And process subject matter experts can use this platform to do the assessment of the devices, and also they can do the monitoring and management. Right? And also the maintenance personnel can make use of this platform to do assessment and monitoring. And also for the different companies, their inter-company maintenance platform can be connected to this collaborative platform, so that their data will be available to the different stakeholders here. And also with this platform, it will enable shop floor and business information sharing in a more security way. And with this platform and the cross-company collaboration, outsourcing of maintenance, specialized partners can now bring in their experts and monitor remotely devices on the shop floor and maintain them. So that can also be a new business model. So for nowadays, the maintenance usually require the people to go to the site in person. So that will take a lot of time and travel cost. But with the proliferation of IoT, so outsourcing of maintenance will be a common model. And the assets on which companies operate may in future not be owned by the company as such, but instead be provided to them over specific service level agreement. So actually, this is a very, well, in my opinion, it's a little bit future. So instead of what it means here is that instead of owning a device, basically they purchase a specific service. For example, instead of purchasing a production line maintained by the company, they may purchase a service level agreement of a production line with an uptime of 99%. Basically, this is achieved and maintained by the respective service provider. What it means here is that the production line is a service, and the service provider will take care of the production line so that it can work 99% of the time, so that the company itself does not need to pay attention pay that much attention on the maintenance of the production line. They just need to focus on their core business. That's for the e-maintenance based on the asset management. Another typical example is the hazardous goods management in the IoT era. So it is the hazardous goods management. Basically, the idea is quite straightforward. Proximity of stored incompatible goods. For example, goods that could be flammable if brought together, or incident compliance guidance will raise alarms locally and at the enterprise system. That will need to be resolved. So traditionally, we have the RFID to do this, for the product asset monitoring. But with the development of IoT, so now people are using the wireless sensor networks. So for the network that can execute business logic locally and communicate among each other, among themselves. So as we can see, so there are different objects in the manufacturing process. For each object, there is a device, or sometimes it's just a sensor that can carry out some logics and communicate with each other. So a typical demonstration of high IoT and large health hazardous goods management scenario is shown in the figure below. So what it does is that, okay, originally we have some drums, DRUM drums, there containing some kind of material. And then when people bring another material that may cause fire with the original material, then the sensors can feel each other, and then they will give warning, maybe give a noise there to the operator, so that the operator something wrong has happened, so he can figure out what's happening. And also, the warning will be sent out to the business monitoring enterprise systems, so that the upper level, for example, the manager, the facility, can know about it. Basically, that's the back end, so they can also take proper action on this. So two things here, we have the on-site warning, and for the enterprise system, we also have a warning. So the wireless sensor network bridges is also capable of not only providing the backend with wireless sensor network information, bottom to up communication. Basically, they can tell the backend what's happening on the floor. On the other hand, the backend can also update, for example, update the software or the firmware in the, for example, the chemical incompatibility list may be extended, or the mass storage limits may be increased or reduced. So for example, maybe several years ago, so material A are considered to be compatible with material B, but recently people found that, okay, they are really not that compatible. They may be dangerous to put them together. So the backend system can actually update the devices, the sensors on the drums, liquid drums, so that now if A and B are too close to each other, the warning will be triggered. So the paragraph here describes the process I described just now. Okay, the real-time interaction at the point of action have profound benefits. The real-time interaction means that the warning triggered on the floor. Basically, that's here. So what's the benefit here? Basically, the field personnel can take corrective actions. So they don't need to wait for the backend to ask them to do something. Basically, by receiving the alarm, they know they have done something wrong and they can take reaction quickly. The connection with the enterprise system offers additional benefits, linking asset management process with its real-time status of field. Here, so these are the two examples, the e-maintenance and the goods management. So to conclude, for the asset management, we are now having the proliferation of cross-layer IoT interactions. So new novel solutions are coming every day. Although there are some challenges, there are also overwhelmingly huge potentials and benefits.